Trigonometry, Chapter 4 review. So we have convert between degree and radian mode and coterminal angles. So draw each angle in standard position, state two coterminal angles, one positive, one negative. Convert to degree or radian, whichever form it currently is not. Okay, so we have 135 degrees, which falls between 0 and 360. I always label my axis 0, 90, 180, 70, 360. We're rotating about 0, 0, starting on the x-axis, and then we're going 45 plus, not past 90, or 45 less than 180. So it's going to end up right in the middle. And we draw our little angle in here so we know that it's coming from here to here. Because if we actually went this way, which we don't want to do, showing that one, then it would be a negative angle, totally different. So we don't want this. So this is going to be 135 degrees. Now to get coterminals, we want something that's going to land on the same arm. So remember, to get a coterminal, you're going to do 360 plus 135, and it's going to terminate on the same arm. Or you're going to do 360 minus 135, and they'll terminate on the same arm as well. So we're trying to find angles that are coterminal, so they terminate on the same arm. So if I go 135 degrees plus 360 degrees, I get 495 degrees. And when I do 135 degrees minus 360 degrees, I get negative 225. So if they're asking for a coterminal, they'll usually restrict your domain so that you can't give them infinite number of answers, right? Because I could just keep going. I could add 360 a whole bunch of times or subtract 360. Convert to degree or radian. So we have degrees to radians, pi on top, Dr. Pot. So we multiply it by pi over 180. And you get 3 pi over 4. Okay. Now we're going to draw 5 pi over 6. So we label our axis 0, pi over 2, pi, 3 pi over 2, 2 pi. Yeah, you could do this all in degrees if you wanted to convert them to degrees, then draw it. But you're still going to have to show everything in radians because the question is in radians. So 5 pi over 6. Our x-axis, rotate about 0, 0. 5 pi over 6 is actually 150 degrees. So it's going to end up being here. But we don't write 150 degrees. We write 5 pi over 6. Because we're not doing degrees. Okay, coterminals. You could technically do 150 plus 360 get an answer, 150 minus 360 get an answer in degrees, and then convert to radians. But I'm going to go straight from radians. So I'm going to go 5 pi over 6 plus 2 pi. In order to add them, we need a common denominator. So we're going to get 5 pi over 6 plus, I'm going to multiply this one by 6. So we're actually going to get 12 pi over 6, which is 17 pi over 6. And we're going to go the opposite way, 5 pi over 6 minus 2 pi. Same thing's going to happen, but we're subtracting. So 5 pi over 6 minus 12 pi over 6 is negative 7 pi over 6. And then it's in radians, we want to convert to degrees. So degrees to radians, pi on top. The radians to degrees, pi on bottom. You get 150 degrees. Now, 4 is radian. And the only reason why we know that 4 is a radian measure is because it doesn't have a degree symbol. So, where would 4 fall? So we have 0, we have pi over 2, we have pi, which is 3.14159, so 4 is going to fall in there. And we have 3 pi over 2 and 2 pi. So 4 is going to fall in the third quadrant, which means pi and 3 pi over 2. 3 pi over 2 is 4.7, and pi is 3.14, almost selectively in the middle-ish. Use different color. So it's going to be 4, and then we're going to find coterminals. So we're going to go 4 plus 2 pi, which is honestly as good as it gets. For those of you trying to put that together, you're only going to get a decimal, because 2 pi is 3.14, so 6.28 something 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 plus 4, and then you'd have a decimal. But I'm going to leave it as 4.2 pi, 4 plus 2 pi, and then 4 minus 2 pi. But you could turn it to a decimal, but if it said exact values, that would have to be your coterminals. And then converting from radians to degrees, pi on bottom. So in this case, you actually have to put the pi in, or else you have to tell me that it is 720 divided by pi degrees, which kind of seems weird as a degree. So if we divide it by pi, it's actually 229 approximately. I should do a little squiggle. It's not really equal to, because we're rounding. It's approximately 229.183 degrees. So it's about 49 past 180. So it's just a little bit further. Okay, then we have arc length. So theta equals A over R. That formula is given to you at the very top right-hand side. So you do not need to memorize it. But what you do need to remember is that theta has to be in radians. If it's in degrees, you have to convert it. If they want the answer in degrees, you're going to get an answer in radians. You're going to have to convert it. So we have a question here. The ring road around an eastern part of the city of Regina is almost a semicircle. Here's the ring road. Almost a semicircle. Estimate the length of the ring road from A to B. So we keep going here. So they want us to estimate the ring road from A to B if the radius of the circle is 4.9. So if we start here, we're going to say that this here is 4.9. And they want the arc. So we're trying to find the arc. We know the radius is 4.9. We know that the angle from here to here is 110 plus 97, which is 207. So theta equals 110 degrees plus 97 degrees, which is 207, which is a lovely answer. However, if you use that and you get an answer, that answer will be on your diploma, I would bet. However, it's not right, because theta has to be in radians. So you're going to have to multiply by pi over 180. As degrees to radians, pi on top, Dr. Pot. So we get 23 pi over 20. Now we're going to use that. We're not going to use the decimal of that. We're going to use that because we want to round in the very last step always. So theta equals A over R is our formula, but we want A by itself, so we're going to multiply by R. So we get A equals R theta. So A equals 4.9 times 23 pi over 20. You multiply it by 4.9 and you get 17.7 kilometers. Okay, unit circle. When you hear on the unit circle, you should think x squared plus y squared equals 1. Well, why is that? Because the circle's formula is x plus the center of the circle on the x. It's minus, but same thing. In this case, because you can minus a minus 0 or minus plus 0, whatever, it doesn't matter. Plus y plus 0 squared equals 1, let's say, or y minus 0 squared and equals the radius squared. And the radius squared is 1 squared on the unit circle, so that's why you get x squared plus y squared equals 1. So we have determined the value of y for the point 3 divided by 10, 3 tenths, y, in quadrant 4. In quadrant 4, we have a point. My coordinate is 3 over 10, comma, negative y, because y is a negative in that quadrant. And that's how they're telling you that it's negative. They're saying it's in quadrant 4. And they're saying on the unit circle, so they're telling us to use the formula. So we're going to get 3 over 10 squared plus y squared equals 1. 3 over 10 is 9 over 100 plus y squared equals 1. We're going to get y squared equals 1 minus 9 over 100. 1 is just 100 over 100. So y squared equals 91 over 100. When I take the square root, I have to remember to take plus or minus. So I'm going to get y equals positive or negative root 91 over 10. Now, why is that? Well, in grade 10, you were taught that if you have a full radical underneath, you could actually write it split. So you could write it as root 91 over root 100. And the only reason why you would do that is if one of them has a nice perfect square, like 100, then you'd get root 91 over 10, and our denominator's rationalized already. Okay? So it's going to be negative. So y equals negative root 91 over 100. It's root 91 over 10. I took the square root of that. So that's my answer, not 100. They want us to determine the coordinate at 23 pi over 6. So if you want to find out what that is in degrees, go ahead. So 23 pi over 6 times 180 over pi. 23 times 180 divided by 6 is 690 degrees. And if we find the terminal arm to that, so we subtract 360, if we find the coterminal, we actually get a coterminal at 690 minus 330, because our point on the terminal arm doesn't matter if you rotated 14 times or you rotated once and you landed on that terminal arm. That point is the same. So minus 360 equals 330. So whether I draw 690, like 0, 90, 180, 270, 360, and it keeps going. So whether I go 360 plus another 330 gives me this terminal arm, which has a coordinate, or I do 330 directly, which would get me to that same terminal arm. It would have the same coordinate. I drew 300, not 330. It is a reference angle of 30. So the coordinate at that point is root 3 over 2 and negative 1/2. Now you could check these. You could go, because this is cos and this is sine, right? So you could go cos of 23 pi over 6, and you could do sine of 23 pi over 6. But because you're pressing sine or cos, you need to make sure you're in the correct mode. And because we're putting in radians, we need to be in radian mode. And sine of 23 pi over 6 is actually negative a half. And this one is root 3 over 2. So we know we're right. It's going to be the decimal that is the same as root 3 over 2. The next one says determine the value of theta when, so I'm asking you for an angle. So I'm giving you the outside of the unit circle, and I want an angle on the inside. When 0 is less than or equal to theta is less than or equal to 2 pi. So I know, ooh, that's not a very straight line. So I know that our x is negative and our y is positive. So I know that my point is in quadrant 2. I also know when my x is a half, it's a 60-degree reference angle. So it's going to be here. And I'm trying to find theta between 0 and 2 pi. So it's in radians, I need to have radians. Now, this point here is at negative a half and root 3 over 2, which is actually a 60-degree reference angle. Or if you have your unit circle memorized and you can repeat it, you should just be able to get this answer. It's going to be 120. Which is great, 120. However, it asked for it in radians, so I can't actually give that answer. I can't stop there. My answer is actually going to be 2 pi over 3. And I box that with the theta. This one wants us to determine the exact value. Exact value usually is a hint that you can pull stuff off of the unit circle. I'm giving you an angle, so I'm asking you for the answer. So off the outside of the unit circle, I'm giving you an angle on the inside of the unit circle. So 5 pi over 4, if it makes it easier for you, you can convert to degrees. And you get 225. Or if you have your unit circle drawn, you'll have that number on it. If you're going to have a coordinate like on the entire unit circle, you're going to have a coordinate at 45. And that coordinate at 45 is going to be negative root 2 over 2, because x is negative in quadrant 3, and negative root 2 over 2, because y is negative in quadrant 3. Okay? It's asking us for cosecant. Cosecant is the flipped version of sine. Sine is my second, my y. So sine of 5 pi over 4 equals negative root 2 over 2. Cosecant of 5 pi over 4, which is this bestie, is negative 2 over root 2. And then we have to rationalize that denominator. We multiply by root 2 over root 2. So you're going to get negative 2 root 2 over 2, an equal sign, and my 2's cancel, and I'm left with negative root 2. Then I have cotan. So cotan of negative 2 pi over 3. So that negative 2 pi over 3 is equal to negative 120. If that's hard for you to visualize, add 360 and get its coterminal and use that, because it's going to terminate on the exact same answer. So that's positive 240. Okay? It's going to get me here, this point on the unit circle. This coordinate on the unit circle is going to be negative a half and negative root 3 over 2. I want cotan. Cotan is cos over sine. So cotan of negative 2 pi over 3 is cos, which is negative a half, divided by sine, which is negative 3 halves, or negative root 3 over 2. Sorry. Then you invert and multiply what you're dividing by, so you flip and multiply. Just the second half, what you're dividing by. And we're going to get these canceling. So you get negative 1 over root 3 but then I have to rationalize my denominator. So I get negative root 3 over 3. And then sine of negative 405. So if I do negative 405 and I add 360, I'm going to get negative 45. That's still not on the main circle, so I'm going to go negative 45. I'm going to add 360 again. And I'm going to get 315. So then when I go to draw that, negative 405 is going to land on the same arm as 315, which is at a 45. So here. So on this edge is my unit circle point. And the coordinate on my unit circle at the 45 is going to be root 2 over 2 positive because x is positive in quadrant 4. And then negative root 2 over 2 because y is negative. Now, if you have your unit circle drawn out instantly, these are really fast because they're already drawn for you. Okay? I want sine. Sine is y. So sine of negative 405 degrees equals negative root 2 over 2. Okay, when we want to solve and the answers are not directly answered right off the outside of the unit circle, you have to follow your 3 rules, or 3 steps, sorry. First step. So to get the reference angle, we want the angle in the first quadrant. If we want the angle in the first quadrant, because the first quadrant angle is the same as the reference angle, because remember your reference angle is your angle from the x-axis to the terminal arm. And in this quadrant, the reference angle is equal to the actual terminating angle. So when we want to find the reference angle, we want to find reference theta, we do tan neg 1 and always positive. Whether the answer is actually negative, that's great. We'll use cast rule to get the correct spot. But we're going to use positive to get our reference angle. Okay, put it in degree mode. Make sure your calculator is in degree mode. Remember, your calculator needs to be in a specific mode when you go to press sine, cos, or tan. So we do second tan. The moment we press tan, we think, what mode do I need to be in? Oh, degrees. So then I put in second tan 3.078, and I get a reference theta of 72.00173129 degrees. Step 1, reference angle done. Yay, check mark. Step 2, cast rule. So it's tan, and now we look at the sign. Oh, it's tan negative. Where's tan negative? Tan is negative here. I'm going to draw a 72-degree reference angle here and here. So this is 72.00173129, and so is this one as well. They're both 72.00173119 because the reference angle is the angle between the x-axis and the terminating arm. So for this one, if I go 180 degrees minus the reference angle, I'm left with 107.9982687 degrees. Great. Now to get this one, I'm going to do 360 minus it, because if I minus this from 360, I get here, which is the terminating arm. So 360 minus 72.00173129 degrees. And I get 287.9982687. But I don't stop there because the domain is restricted to be between 0 and 720 inclusive. So if 0 was an answer or 720 was an answer, I would include them. So I have to add 360 degrees and get an answer. And I have to add 360 degrees and get an answer. So for this one, I get 467 0.998267. And then if I add 360 to 287 point blah, 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 I get 647.9982687. So this one actually has 4 answers. So theta equals, whoopsies, theta equals 107.998 degrees, 287.998 degrees, 467.998 degrees, and 647.998 degrees. Because they all fit within the restricted domain. Then we have secant theta equals negative 1.046. And if negative 180 is less than or equal to theta is less than or equal to 180. So we want to solve for theta. So we would do secant theta is great. However, we don't have a second secant button. So we'd have to do cos theta. And cos is just secant, the answer to secant flipped. You can flip an answer. You cannot flip an angle. We've said that over and over and over. You can flip an answer. You cannot flip an angle. So I'm going to flip the answer to 1 over negative 1.046. Now, I'm going to second cos that to get my reference theta. So I'm going to get cos neg 1 of 1 divided by 1.046. As you notice, I'm not using the negative sign again. Okay, so second cos 1 divided by 1.046. My domain is in degrees, so my answer is going to have to be in degrees. When I second cos that answer, I get reference theta equals 17.0551395 degrees. Then after I get my reference theta, I use my cast rule. Cast says that it's cos negative or secant negative. Where's cos negative? Cos is negative in quadrant 2 and quadrant 3. And in here I have my reference theta, which is 17.0551395 degrees here and here. So how am I going to get my answers? Well, to get this answer, I'm going to go 180 minus 17.05 dot dot dot. And to get this one, I'm going to go 180 plus that reference angle, 17.05 dot 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 dot. So if it's in quadrant 1, the reference angle is equal to the angle. If it's in quadrant 2, like this one here, like that, I'm going to do 180 minus my reference angle. If it's in quadrant 3, I do 180 plus my reference angle. If it's in quadrant 4, I do 360 minus my reference angle. So I get 180 minus 17.05 whatever. And so theta equals 162.9448605. And that fits my domain, so good. If I subtract 360 from it, I get negative 197, which is outside my domain. So the coterminal is not going to fit. If you remember, we just checked the coterminals to see if they fit in the domain, and they won't. So if I subtracted 360, I get negative 197.055, etc. And that is bigger than 180, negative 180. So it's out of the domain. Now my second one, I'm going to do 180 plus 17.05, whatever. And I'm going to get 197.0551395. Now that's outside of my domain because it's bigger than 180. So it's not going to work. So I'm going to subtract 360 from it and see if maybe that coterminal is there. Subtract 360 and I get negative 162. Do these always match like this one happens to be matching? No, not whatsoever. So this one is too big, so it's out of my domain. So my answers are, I only have 2, and their theta equals negative 162.945 degrees and 162.945 degrees. Now remember, you guys, look at this. This is an equation. Secant theta equals negative 1.046. So it's secant theta equals negative 1.046. Well, it's an equation with an equal sign, right? If I have an equation with an equal sign, I can type into my calculator. So my equation is secant, oh, it's not going to let you write it here. Secant theta equals negative 1.046. So I have to type secant theta into y1. Well, I can't type in secant theta, but if I look at my formula sheet, secant theta is 1 divided by cos theta. So that's secant theta. And then on the right-hand side, I can go negative 1.046. So unless this is an algebraic one, you could always check it this way as well. I'm going to go to my mode, make sure I'm in degree. I'm not. And then I'm going to go to my window, and I'm going to restrict it to be the same domain. So the domain was negative 180 to 180. Oops, negative 180. 180. Make it go by 45, let's say. Negative 4 to 4. See how many times it crosses. Oh, twice. One here, in this red, and one here. So I'm going to find them. So I can trace 5, and I only care about, I can arrow down to get onto this one. I only care about the x value. Okay, I'm close to here. Enter, enter, enter. Negative 162.9449, which was one of my answers. And so I can trace 5 all the way over to the other one. Oops, pop up. Take forever. Closer to this one. Enter, enter, enter. And 162.9449. So you can check these with your calculator. You can check any equation, and I've told you this before. You can check any equation that has an equal sign and one variable by punching it into y1, y2. So we could have done it with tan theta equals negative 3.078 and restrict our domain between 0 and 720 and make sure it's in degree mode. Now the next one say give exact values. These ones are easier because I don't have to get the reference angle because this answer is right off my unit circle. So I want to know when y equals negative root 3 over 2. So if my unit circle was drawn, I would see that at the 60s degree reference angles, or the pi over 3s, down here, because y is only negative down here, is where I have the coordinate. This one would be negative a half and negative root 3 over 2. And this one would be positive a half and negative root 3 over 2. So sine is negative either way in both these spots. Okay? So that's at my 60. Now, those are the ones that are over 3. So if I go 180 plus 60, 240 divided by 180, I'm going to get 4 pi over 3 is the answer to this one. And if you looked off your unit circle, you directly have it. And then this one is going to be 5 pi over 3. And those are great answers, but I also have to check because this is between 0 and 720 technically degrees, or 0 and 4 pi. So I actually have to get the coterminals because there's going to be 2 more. So if I go 4 pi over 3 plus 2 pi, I'm going to get 4 pi over 3. I need to be over 3, so I'm going to multiply by 3 and 3. So I'm going to get 6 pi over 3, which is equal to 10 pi over 3. And then I'm going to have 5 pi over 3 plus 2 pi to get the coterminal. So I'm going to get 5 pi over 3 plus 6 pi over 3, which is 11 pi over 3. So I have 4 answers. They're going to be 4 pi over 3, 5 pi over 3, 10 pi over 3, 11 pi over 3. Now cosecant theta equals 2. Great, cosecant. I want sine. I can flip my answer. I cannot flip my angle. So sine theta, cosecant theta equals 2 over 1. Sine theta equals a half. You flip your answer, not your angle. Where is sine positive a half? In quadrant 1 at a 30, and in quadrant 2 at a 30-degree reference angle. So at 30 degrees and 150 degrees. On your unit circle, it would say that. On your unit circle, you also have radians, so you would put pi over 6 and 5 pi over 6. But it's between negative 2 pi and 2 pi, so I have to find the coterminals negative. So I'm going to do pi of theta equals pi over 6 minus 2 pi over 1, which I have to multiply by 6 so I can get common denominators. So I'm going to get pi over 6 minus 12 pi over 6, which equals negative 11 pi over 6. And then this one's going to be 5 pi over 6 minus 12 pi over 6, which is 2 pi. As a common denominator, we have negative 7 pi over 6. Okay. So theta equals negative 11 pi over 6, negative 7 pi over 6, pi over 6, 5 pi over 6. So now we have determined the value of 5 other trig ratios. Trig ratios are like sine, cosine, tangent, cosecant, secant, cotan. We need to find the other 5. So we have cosecant, we need the other ones. It says cosecant theta equals 5 over 3 and tan is negative. So this is cosecant positive, tan negative. I always tell you to draw a triangle. Where's cosecant or sine positive, but tan negative? Sine is positive here and here. Tan is negative here and here. Where's the doubling up arm? Quadrant 2. So I'm going to draw my triangle in quadrant 2. Now cosecant is opposite sine. Sine your resume, so this is resume your. So I'm going to have 5 and 3. How do I get the third side? Well, it's going to be negative. That's why I have to draw it. If I didn't draw it, I wouldn't know if it was positive or negative, and you need to know. We use Pythagorean theorem. So I have x squared equals 5 squared minus 3 squared. X squared equals 25 minus 9. X squared equals 16. X equals plus or minus root 16, because when you take the square root, you have to take the positive or negative. And in this case, it equals negative 4, because I drew it, and I know that this point here, x has to be negative. Now I can give my trig ratios. So I have sine theta your resume. I have cook extra rice. I have tan your Xbox. And then their besties is the opposite. Cosecant I already have. Secant theta is r over x. You flip answers, you can't flip angles. And then cotan theta equals x over y. Okay, so sine theta equals 3 over 5. Makes sense because it's just be the flip of cosecant. Cos theta equals negative 4 over 5. Secant theta equals negative 5 over 4. Tan theta equals 3 over negative 4. Cotan theta equals negative 4 over 3. Last page. So solve first degree trigonometric equations. So the first one is, these are all first degree, so they're linear. So you're going to get the cosine to one side and everything else to the other. If in this case you want to say m equals cos x, so it's easier to solve for you, go ahead. But don't forget to put the cos x back in. So you're going to get 7m plus 5 equals 2 minus 3m. You could check this once again with your calculator. There's an equal sign in only one variable. Restrict your domain, your window, between 0 and 360. So this you could check with your calculator. So we're going to get our m's together. We're just solving linear equations. So we're going to get 10m plus 5 equals 2. Subtract 5. 10m equals negative 3. Divide by 10. M equals negative 3 over 10. And m is actually cos theta equals negative 3 over 10. And now we're just back to where we were before when we didn't have something directly that I could pull off the unit circle. So what am I going to have to do? 3 steps: reference angle, cast rule, answers. So reference theta. So I'm going to get cos neg 1 of positive 3 over 10 in degree mode. I take the positive to get my reference angle. I'm going to get 72.54239688 degrees. And I use cast rule. Where is cos? Negative. Cos is negative in quadrant 2, quadrant 3. In quadrant 2, I go 180 minus the reference angle. So I get 107.4576 degrees. And then in the third quadrant, I'm going to go 180 plus the reference angle of 72. And I'm going to get 252.5424. So it's between 0 and 360, so those are my answers. Theta equals 107.46 degrees and 252.54 degrees. Now the next one just has a cotan by itself, so I'm going to just solve for it. If it's confusing with the cotan, remember you could replace it. We want it in general form, so I want every single answer possible. I'm not restricting the domain. I'm going to subtract 17. 3 cotan x equals 12. And then I'm going to divide by 3. And I want where cotan x equals 4. Remember, I can flip it. So I want where tan x equals a quarter. Now, why would I want to do that? Because I can't, there's no cotan button, but there is a second tan. So reference theta equals tan neg 1 of a quarter. And they would have to specify if they wanted it in radians or degrees for general form. I'm just going to do degrees. So I'm going to get 14.03624347 degrees. And then I have to use cast rule, and it's where tan is positive a quarter. So tan is positive in quadrant 1. That doesn't look like 14 degrees. Tan is positive in quadrant 1 and quadrant 3. And these are the reference angles of 14 degrees. So this is one of the answers, 14.04. And then I'm going to go 180 plus the previous answer, because it's in quadrant 3. I'm going to get 194.04 degrees. So those are my angles between 0 and 360. And then to get the next one, to do general form, I'm going to go, I could put them together only because they're tan. So they're going to happen every 180, because tan repeats itself every 180, whereas cos and sine repeat themselves every 360. So I can actually put these two answers together. However, if it was sine or cos, I would have two general form answers because I couldn't put them together, only tans and cotans. So theta equals, for general form, 14.04 degrees plus 180 degrees N, NEI. Could I give two answers, 14.04 plus 360 degrees N, NEI, and 194.04 plus 360 degrees N, NEI? Yes. Will they probably have that answer? No. Could I give it though? Yes. Last thing for chapter 4, solve second degree trigonometric equation. So solve the necessary round your answer to the nearest decimal place. So why did I pick A? I picked A specifically because it's a squared sign with no other term. So you're going to solve for it. You're going to take the square root of it to get sign by itself, and you're going to have to remember to take plus or minus 1, or plus or minus a half. Because if you don't remember to square root and take the positive negative case of it, you're only going to get 2 answers. So we're going to get sine squared x equals a half, and then we're going to have to square root, and when we take the square root, we have to take plus or minus. So we're going to get sine x equals plus or minus root 1 over 2. So it's not off the unit circle, because off the unit circle is a half, not root 1 over 2. So I still need to get reference theta, which is sine neg 1 of square root 1 over 2, completely in brackets. I need to change my mode to radians. So second sine square root 1 divided by 2. And I get a reference theta of 0.785391634. And this is in radians. Then I know it's in every single quadrant. Here, 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 here. So this answer is correct, 0.78 rads. These ones, instead of going 180 minus, you're going to go pi minus that. You're going to get 2.36 rads. And this one, you're going to go pi plus it. And you're going to get 3.93 rads. And then this one, you're going to go 2 pi minus it. And you're going to get 5.50 rads. Now the catch is it's between negative pi and pi. So these ones are good. These ones I have to find the coterminals of. So I'm just going to subtract 2 pi from them. So 3.93, the whole decimal, minus 2 pi. So I'm going to go 3.9 whatever, minus 2 pi. And I get negative 2.36. I have a degree symbol, that's not true. And then I'm going to do 5.497787, blah, 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 minus 2 pi to get the coterminal. And I'm going to get negative 0.79. So I still have 4 answers. They're going to be negative 2.36, negative 0.79, 0.78, and 2.36. I think it's supposed to be 0.79 and 2.36. Okay. Now remember, we could have typed this into our calculator. y1, y2. Change our domain to be between negative pi and pi, and we get the same 4 answers. This one has a few tans, so I'm going to make m equals tan theta. I'm going to get m squared minus 4m equals negative 3. It's a quadratic. When you have a quadratic, you have to set everything, get everything to one side, set equal to 0. So m squared minus 4m plus 3 equals 0. And then I say what times what equals 3, what plus what equals negative 4, negative 3, negative 1. And we get m minus 3, m minus 1 equals 0, m equals 3, m equals 1, tan theta equals 3, tan theta equals 1. Now cos and sine max out at 1 and negative 1. So if it was sine of 3, sine theta equals 3, I would say no answer. Or cos theta equals 3, I'd say no answer. But tan theta looks like this. It goes on forever up and forever down. It just has some asymptotes, places that don't exist. Like right here and right here, they don't exist. But the graph actually goes on forever, YER. It's just that X doesn't exist in some cases. So tan theta equals 3 is just fine. Tan theta equals 1 at 45. 1 and negative 1 at 45. Tan equals positive 1 in these two quadrants, because that's where tan is positive. So it's going to be at pi over 4 and 5 pi over 4. That one's easy. The other one, though, I have to get a reference theta for. So reference, because it's not right off the unit circle. Theta equals tan neg 1 of 3. If you forgot that something didn't come off the unit circle, you could still do the 3 steps, reference angle, cast rule, answer for your angles, and it would still work. It's just faster off the unit circle. So I'm in radian mode. I go second tan 3, and I get reference theta equals 1.249 dot dot dot. And I use my cast rule. It's tan positive 3. Tan is positive here and here. So this is the answer if it's in quadrant 1, so 1.25 rads. And then I'm going to go 2 pi plus that long decimal. And I'm going to get, sorry, pi plus that long decimal, not 2 pi. And I'm going to get 4.39. So my answers are theta equals pi over 4, 5 pi over 4, 1.25, and 4.39.